Today we're going to have a look at completing the square to solve a quadratic equation. So first of all, we need to look at our equation in descending powers of x. And the easiest way to do this is to keep the x squared and the x term on one side and take the constant term to the other side. So we're going to start off by doing that. And of course, when the negative 3 moves across, it's going to become positive 3. Then we're going to do exactly what the name of the method tells us. We're going to complete the square on the left-hand side. So we're going to turn the left-hand side into a perfect square trinomial. So I first of all start off by writing down my two terms that I have already. And then I take the value of my coefficient of the x term, which is 2. I halve it, which gives me 1. And then I square that. And 1 times 1 is still 1. And that term will always be positive because of the fact that we're squaring it to get the final value. Then remembering that in any kind of equation, whatever you do to the left-hand side, you need to do to the right-hand side. So if I had 3 on the right-hand side, then I have to do exactly the same as I did here. So I have to add 1 as well. Now, if I've turned this into a perfect square trinomial, it will factorize into a bracket squared. So how do I find out what's going to be in the bracket? I square root the first term, which will give me x. I square root 1, which will give me 1. And I take the sign of the middle term. And then on the right-hand side, I'm simply going to simplify. 3 plus 1 is equal to 4. And now I don't want this situation of having a bracket squared. So I know that squaring and square rooting are inverse operations. So if I were to square root this side, the square root sign and the squared would cancel each other out, and I'd be left with x minus 1. But again, whatever I do to one side, I have to do to the other side. And here we have to be careful that we find the positive or negative answer to the square root. So this side is going to give me just x minus 1. And the square root of 4 is 2, but I have to consider that positive 2 is the square root of 4 because 2 times 2 can give me 4. But negative 2 is also the answer to the square root of 4 because negative 2 times negative 2 would also give me 4. So it's very important that you remember both those possibilities, otherwise you're not going to get your second answer. So my two possibilities here are that x minus 1 is equal to positive 2, or x minus 1 is equal to negative 2. And now solving for x, of course the 1 will become positive, so 2 plus 1 is 3, or x is equal to negative 2 plus 1 is going to give me negative 1. And those are my two solutions for the equation. Right, let's have a look at another example where we've got something a little bit different this time in terms of a fraction as our constant. But again, whether we've got a fraction or a whole number, whatever we've got as our constant number, we need to take it to the other side to start. So I've got y squared plus 2y is equal to negative a quarter. And then I've got to complete the square on the left-hand side. So always write down what you've got to start with. And then again, we're going to say, look at the coefficient of the y value. So coefficient of y is 2. Halve it. Half of 2 is 1. And 1 squared is 1. So we actually happen to have the same situation that we had last time, but it won't always work out like that. And then remember, write down what we've got on the right-hand side, and whatever you did to the left-hand side, do the same to the right-hand side. I'm now going to write this as a bracket squared. Square root the first term, square root the last term, and take the sign of the middle term. It's as easy as that. Negative a quarter plus 1 is going to give me 3/4. And now again, I'm doing this in orange because you can do this in your head. I'm just putting it into remind you of the methods that you're using here. As soon as I square root something that's already squared, I'm simply left with what's inside, so y plus 1. So here I'm square rooting an entire fraction. So the top of the fraction is not a perfect square, so that's going to have to remain plus or minus the square root of 3. I can't simplify it further. And very often in these types of examples, they ask you to leave the answer in surd form. And surd form means leave the answer with a root sign and don't convert it into a decimal. The bottom of my fraction, the denominator, is a perfect square, so the square root of 4 is 2. So that simplifies down. Then this 1 is going to go across and it's going to become negative 1. And I already have my plus minus root 3 over 2. So that is the answer, but it's nice to give your answer as a complete fraction. So I'm going to combine these two fractions by finding a common denominator here. Negative 1 has a denominator, an imaginary denominator of 1. So if I wanted to write it with a denominator of 2, I would have to think of it as negative 2 over 2, because anything over itself is 1. So considering it as negative 2 over 2, then I can write it all with a common denominator of 2. This is negative 2 plus or minus the square root of 3. And that's the best way to leave your answer in that form. And that is giving you the two options, because if you were to calculate it on a calculator, you'd say negative 2 plus root 3 over 2 or negative 2 minus root 3 over 2. But look carefully at the beginning of each question, and if they specifically ask for the answer in surd form, make sure that you leave it in this type of form. We will be doing another example on completing the square, where we have a coefficient for the y squared to start off with, and that just adds another extra step at the beginning. So look out for that video, please.